All right, so here's a few news articles that I thought were interesting. A lot of people are getting interested in wearing face masks. I went and got one. I had some around from my last planned trip to China, which was canceled. So I've been wearing them as just to set a good example. I'm pretty sure I don't need one, but it's a lot of people are thinking it's a very good idea to wear a mask. And it's actually a very interesting issue for security professionals because I watch when people complain when Trump says something stupid, like he touts some unproven drug and some idiot finds some other product with that drug in it and takes it and dies. And then they say Trump shouldn't have said that. So what they've been saying is, even though it's obvious that masks will protect you because doctors wear them, if they say people should wear masks, they will desperately buy all the masks they can find and there won't be any for the doctors. So you could tell them that. You'd be safer with a mask, but as a altruistic thing, you should not get a mask. But they probably correctly feel like many Americans will just say, to hell with you, I'm going to get my own mask and the doctors can just die. So they lie to them and say the mask won't protect you because that will lead to the desired results. And this is a very tough problem. I mean, especially in this administration, but I think also in the government of China and elsewhere, leaders frequently decide that the truth is too dangerous, and instead they will tell the public a lie to try to get them to do the right thing. And it's not so simple as saying nobody should ever do that, and everybody should always have the whole truth all the time. It is a difficult balance of risk and reward. Anyway, but now people seem to be catching on that we can tell people to wear masks and they can make their own masks out of things like bandanas and t-shirts and paper towels, and that would be better than nothing. Google is launching a new service. They already have a Google Cloud Storage and Google processors and other services, and now they're going to have a memory in the cloud. And I don't really understand exactly what Memcached is. If any of you people have used it or know more about it, please let me know. But now you can get memory in the cloud, a fully managed in-memory data store. So it sounds pretty good. It reminds me of a feature that was supposed to be in Windows Vista. When Windows Vista was about to come out, Microsoft said they were going to let you use memory in other computers in your local area network to store things when you run out of RAM. They decided not to do that, but it sounds like a similar issue. And I guess if you can store your data on somebody else's disk space in the cloud, you could stick it in the memory in the cloud. That would be faster. So it's an interesting idea, and I'd like to know more about it. So here's a, in the mobile device hacking class, we've been talking about cached passwords and API keys in the code. And here's a guy that found an API exposure in the mobile app, and he was then able to make malicious redirects, so he got $600 for it. So sometimes you can actually get paid for that kind of vulnerability. I did get paid for some of the ones I found over the Christmas break. I think somebody paid me a couple $100 or something. But you don't make a lot for the kind of vulnerabilities that I know how to find. But it is interesting that, and the API key exposure is, of course, very easy to find. And passwords, you just find a string, just write in the source code. And Android apps are distributed with essentially the source code. It's in Smalley, which is almost the same as the original Java code. So Amazon is under a lot of attack by people because they're running a lot of people in the Whole Foods stores and a lot of people in the warehouses. They're showing up for work and they are complaining that they don't have enough protection and they feel like they're getting exposed to the virus. And they've been having sick outs and strikes and stuff. So they're going to start giving you a temperature check to get in, which I saw all over Asia. Everywhere I went, the airports and everybody has big temperature checks and you have to be scanned to see, make sure you don't have a fever before you go in. Amazon's going to start doing that, and they're going to provide masks. So that sounds like a good thing to do. And this, I would think, is probably going to become the standard all over America. I think we are going to look like Hong Kong and like China, where everyone's going to wear masks, and every time you go into any kind of public building, they're going to check your temperature, and we're just going to get used to it. They've been doing it for years over there, and we clearly have to do the same thing over here. So everybody in the last week has been freaking out about Zoom. We're using Zoom right now. There were some sort of high school and elementary teachers that got Zoom bombed, where some student would join and then share their screen, and they'd be playing pornography on their screen. And this would freak everybody out. And so people have freaked out. They banned one college or high school district, banned the app, saying nobody should use it. Also, you can post links in the chat, and if people click on them, it'll open local resources and perhaps even launch applications. And there are other security vulnerabilities. So Zoom has declared that they're going to cancel all new features for 90 days and just fix all these vulnerabilities. Zoom is incredibly popular. Their stock is doing very well. Everybody is using it for the same reason we are. It is the easiest way to chat with a bunch of people in real time. And most of the vulnerabilities aren't too fatal, I think, but a bunch of people are freaking out about them. And Zoom clearly has to patch this stuff before people get fed up and all switch to something else. I think Zoom is so easy to use. I'm going to keep using it. I don't really care about any of these vulnerabilities, and I assume they'll patch them. But all my stuff is public anyway. All right. Anyway, so I have taken part of some Amazon class in security, in cloud security. And the main thing I learned is they have a bunch of security features, but they all cost money. So I can't really give my students much projects in them, but they have a lot of them. And now they have another one. And I don't really understand why there are so many or what they all do. They've now got one called Detective. So this analyzes logs to track down security products, which make it sound kind of like Splunk, except of course it's got AI, which as far as I know, Splunk does not have, although I think they do have some optional feature that adds AI to it. The product I know that has AI is IBM's QRadar to do the same thing. And so GuardDuty uses machine learning. Then there's Inspector, which assesses applications. Then there's Macy, which uses machine learning. Then there's Security Hub. And then there's Detective. So they have like 5 different things that all seem to do approximately the same thing. So it is pretty confusing. And I don't understand them, and I wonder how many people really do. But anyway, Amazon certainly has a lot of security products if you can just figure out what they all are and which ones you should be turning on and paying for. I don't think I'm going to bother with that one. This was amazing. This guy was driving the train when he saw the hospital ship coming in, I think, Los Angeles, and he deliberately crashed the train to ram into it. And when they picked him up, he said this was because he's sure there's some kind of government conspiracy involving that ship. And he felt like he was making people aware of the government conspiracy. And he's really looking forward to seeing the videos on the news about him doing this. And it's perfectly fine if he goes to prison for doing this because he's exposing the truth about something. It's very unclear what he's talking about. It sounds a little bit like the QAnon stuff, but some kind of bizarre government conspiracy is motivating this guy. That was very strange. And it only got half a minute. Here's, by the way, there's all kinds of chat rooms where people plan these Zoom bombing raids. One of the questions I wondered is how they're getting the URL for them. And some people say you can write scripts to hunt through URLs until you find a valid Zoom URL. But what a lot of people are doing, there's just chat rooms on Discord channels and other places where people just post them and they organize them saying, crash my class next week. A lot of ordinary high school students and stuff. So that would seem to be the easiest way to do it. And this one is pretty interesting. They have figured out how to take the reflections off a bag of potato chips and reconstruct it to see what's in the room. Even when a human looking at it can't really see that. So these kind of reflections here, on the shiny bag, that is pretty interesting. And they say they can reconstruct what's in the room to some resolution this way. And they can also hear sounds in the room by looking at a video and watching the plastic move with the vibrations of the sound. So that would seem to me to be an interesting vulnerability for people who send pictures or video around. Even objects that you don't think of as mirrors might still be functioning to expose what's going on in that room. Anyway, so now we're up to the official time for the class. So let's talk about this. City College is closed for the next month anyway, until the end of April. And I think the last word I saw on the website is definitely closed until the end of this semester. And a lot of people are, I'm hearing rumors that it's probably going to be closed all summer and in the fall too, although that has not been finally decided yet. But I don't think the college gets to decide that. It's really going to be the mayor and the governor and perhaps even the president declaring these shutdown orders. But realistically, all the classes are going to be online only. There will be no labs, no ability to get in the college rooms at all. I can help you here. I'll hold on my classes as usual on Zoom, and you can, after the lecture, I can help you on your projects. You can share your screen with me so I can see it. And so it would be somewhat like me really being there. Now some students have, one student told me that they don't have any good internet connection. And that is a real problem. And they were counting on the college to provide the internet connection. So I want to mention you can get a cheap internet connection device. See if I can find it. I think I called a hotspot. Yeah, right here. This link here, it's my April 1 news links. If you go to collegebuys.org, you can get a hotspot, which will get you on the internet for $20 a month. And it's pretty good. It's fast enough to do anything we're doing. So if you don't have a good internet, this would be one option. So check it out if you like. It's here on somewhere in my April 1 links. And let's see if you got any questions, let me know. I don't think I have any chat messages at the moment. Okay. But let me know in the chat if you have troubles or any questions about anything. So I've updated the schedule. We missed 2 weeks because of spring break and the early chaos as San Francisco all shut down in response to coronavirus. So we're picking up here. And so I've moved a couple of classes around here. We're now on chapter 10, and we'll just carry on from there. I have 2 extra classes that aren't filled yet, and I'll announce what we're going to do there in the next week or 2. So let's take a look at the slides for this one. Let me make them big for the moment. All right. And all right, I guess I can do it this way. So we're talking about back-end components. And let me see if I can get rid of, okay, what's going on here? All right, just a moment. I'm going to get rid of some of these screens and put them on my other window. All right, I got 2 screens, which is a little different than my normal setup, and I'm figuring out the best way to handle it. So, there it is. Good. Get this out of here. All right. So we've done command injection. You had that ping form where you can put in an IP address and you can put in a semicolon and add more commands. And there are a lot of other vulnerabilities that work the same way. So you can, if anybody that writes code where it just executes a system command can create this vulnerability. So here's how it looks in Perl. You have a command created here with du -h, which will tell you disk usage. And this is disk usage in a directory. And it includes a parameter, dir, which came from the user. So although it's not incredibly obvious here, this does have the same effect as that ping form. It creates a Unix command that executes as if you had typed it in, and it includes text that came from the user. So they can inject code, and here's what happens. They expect you to use it this way. If you look in the URL bar, you see dir = public, and so it tells you the contents of the public directory. But if you put in dir = public and then a pipe command, and then cat password, it executes the second command there. It's a pipe is one of the things that lets you put 2 commands on a line, like a semicolon and some other punctuation marks. So that's the same kind of command injection we did with the ping form. In the real world, here HP OpenView had the same problem. You could go to a HTTPS page, and in the node, you could put in a pipe and then put in a command and put another pipe at the end, and it would execute it. Just like in the projects you did, the ImageMagick library. This is a real problem that keeps happening in a lot of real world directories. And by the way, in the news links about a week ago, there was one I haven't brought up yet, but it's very interesting. Someone scanned the WordPress source code and found dozens of WordPress extensions that are structured this way. They execute a Unix system command. And he said, all you have to do is look in them and you'll probably find a bunch of 0 days to report. It would be a very good project if someone wants to try doing it. You just have to find the code that executes a system command and then see if any part of it contains user-controlled code, and then try to develop a proof of concept exploit. It would be a very good thing to do. I may try it myself if I get the time. I think like a lot of people, I'm finding that I'm sort of distracted by the chaos of having to switch to working at home. But I'm hoping after I get more used to it and set up, I'll be able to do more of my normal research. So here's injecting into ASP. Again, there's a user control directory name. You can see them building a command here with cmd and then /c dir and then dir name. So this is just like the ping form. It's got a directory name right there in the command line that is executed as a command line. So you can just put in a double ampersand signed or perhaps a semicolon or something. You can add more commands there. So here's how it's used. Um, you can list the contents of a directory here. And if you give it no subdirectory name, you just get a default list of files. But if you give it a directory name with dot ampersand ampersand IP config, which you see up towards the top of this page, then you get an IP config showing your IP address there. So this is very much like the ping form and other projects you've done there. You can inject into PHP, of course. Here you've got a search page that searches for something, and then it evaluates the stored search. So you get to define a search, and that is evaluated as a line of Unix command, or the operating system commands here, a shell command they call it. So you can put in, any commands you want to evaluate, and they will be run. This is very common. I also found it in one of the Android apps from Harvard that we've been going through. It's a very easy way to write code, to just build the line of command line code you want and execute it, but it's a very dangerous way to write code. So if you want to find these things, just inject some special characters, semicolon, pipe, ampersand, try putting in a few commands, try a backtick is another thing that will cause commands to be executed immediately, and see if you can get any of those to evaluate a command. You might not be able to see the results. It's entirely possible that the command will do something and run, but the output will not be fed back into anything that is visible on your page. So you might have to do something like a ping to cause a time delay, or make some kind of network connection to some other service that you can see the effect on. NSLOOKUP is another one, and that passed input to NSLOOKUP, so it's going to look up the IP address of a domain. Can I put up the background of Dr. Fauci? Oh, yeah. Yeah, I can do that. I saw a comment there. Let's see, I should be able to. Let me see if I can figure out how to do it. If I hit this, I might as well try it. It looks like I'm having trouble with my, there we are. So I'll try for that. I'm getting used to these backgrounds. And before I wasn't even projecting my face. In the last class, a student thought it would be better if I did. So that would be this one, I think. Yeah. All right. Anyway, yep. I'm just getting used to these things. So let's make this big again. All right. So NSLOOKUP, you look up a domain name. So if you give it an invalid domain name, it will then give you an error message, and that will tell you I can't find the domain name and show you what the domain is. So now you can put in script code, and it'll put the error message in the file. So this is a fairly common technique to exploit these things. You take the output, you redirect it to a file, and then you run that file. Sometimes you can run log files or create other files. So if you want to prevent these things, you shouldn't write code that builds a command line and then executes it from the command from the system. That's a very dangerous thing to do. If you have to do it, then you have to filter the input strictly to make sure that the user is not able to put in these control characters. And the best thing is whitelisting, where you let them put in only known good characters, not where you try to remove all the bad characters you can think of. What's much better is to use API calls instead of building lines of command line that are executed, but instead to use the API for the system, where you're passing in parameters, which is probably a lot safer. So again, just avoid doing this. If you have to do it, you have to filter it with whitelisting. So then, of course, file paths are the common one, the most common one being PHP local file inclusion, remote file inclusion. So here's a function, a typical kind of thing. You'll see it in ASP and PHP. This is ASHX, and it's going to get a file, and then it has a parameter called file name. So there's a file name parameter. It's used to fetch a file out of the file system, and if it's not sanitized, you can just put a // there to harvest a file that you're not supposed to see. They're getting win.ini file, which is a really old file left over from MS-DOS, still present in some versions of Windows. I think I saw it in Windows 7. I'm not sure if it's still there in Windows 10, but it's sort of the equivalent of the /etc/password file. It's just a file that is world readable, but you shouldn't really be seeing it. And so if you're able to see that, that indicates a failure to restrict access to the file system. So you may be able to read files or write to files. So you might be able to find a file with a password or parameter setting or a log, or overwrite something like configuration file. You can detect these things with file system monitoring. There are tools that will detect alteration of the file system. Tripwire does it on Linux. FileMon, now replaced by Procmon, On Windows does it. There's many tools that do this, so you can just know if if altering the file system. All right, so if you want to find these things, you can just inject unique string and then filter the file system monitoring tool to see if that string appears in a read or write operation to a file. And then you'll see that you're able to inject something which is then used to write to a file. So here's a path traversal attack. You see up in the URL, file name equals dot dot backslash dot dot backslash Windows win any, and they managed to see it in the browser. So there are often obstacles to block these, filtering or characters that are disallowed. So you can try forward and backslash, either one might work, URL encoding for the dots and the backslash, 16-bit Unicode encoding, double URL encoding in case the application decanonicalizes the data twice, which was true of IIS in some early versions. And you can use overlong UTF-8 Unicode encoding. These are just many ways to encode these fancy characters that may work on some systems. And you can try putting one dot dot slash inside another dot dot slash in any of these ways, like we talked about before. So if they're using a simple grep matching to filter out a dot dot slash, this will just create another one after passing through one round of that filtering. And you can add null characters. If you're out trying to upload something and it has to be an image, this is a way to make a file that appears to be a JPEG to some processing systems, but other processing systems might terminate it at the null byte, and you'd actually be able to refer to a file that is not a JPEG. So this is the problem with having multiple layers of analysis, where the security layer might be something like a web application firewall, which has different code than the actual code behind it that uses the data. All right, and if you have read access, you can just try to find password files, configuration files, database credentials, and include files. There are many places on there. Log files may contain cookies. There's just many things on a server that you really shouldn't be seeing, and you can hunt for them. If you have write access, all you have to do is write a file that will eventually be executed. Now, if you can write to a web directory and execute it directly by just browsing to it, that's the easiest way, but you may have to do something a little more subtle, like create a startup folder and then wait for somebody to log in, and that startup file will be executed, or so on. So if you want to prevent these things, you cannot pass user-controlled data into a file system API or whitelist it strictly. And after, you can try to check for all the dangerous characters, forward slashes, backslashes, null bytes. In general, if you find bad things, you should just stop and make the user try again. You should not try cleaning data and then continue using it. That makes it much easier for the attacker. All right. And so verify, one thing to do is every time they refer to a file, make sure the file is really there before you go there. That would prevent them from creating a new file, and so on. Another thing you can do is put your app in a chroot jail. You can do this on Linux with the command chroot, and you can do it on Unix by mapping a drive letter, referring to everything from a mapped drive letter, and this causes all the read and write activities of that app to be restricted to inside that container, so they cannot get out to the system files or to files belonging to other applications, and that's a very good layer of defense. All right, so include files are all over the place. This is a very common way to do it. You want to have something like a style sheet or some scripts that you're using in JavaScript all the time, so you put them in a separate file and include them in every page. And that's fine. PHP has include functions, JavaScript has it, everybody has include functions. So here's the problem is, all right, there may be vulnerabilities here, and it means if you have vulnerability in one, it'll be vulnerable in all of them. Anyway, here's an example of a country specified in a parameter, and the way they implemented the country is you give it the name of the country, and then it would include that.php. This is, of course, assuming that you're going to put in an expected country abbreviation, and if you don't, and instead put in something like a path on a remote server, it might load a PHP script from a remote server under your control, and now you're able to inject PHP code into the application. All right. Remote file inclusion might be blocked, but you might be able to find a file in local file inclusion somewhere on the server that you can use and do something bad with. So you want to find these things, insert a URL to a server you control, and then look to see if you're getting requests. Insert a non-existent address, so it'll make a time delay. And then if you find the vulnerability, you can then insert malicious code from your server. For local file inclusions, you try for known static files like that win.ini, a known executable, and so on. Just find what you can and see what you can do when you get it. So we can try these cahoots. We're up to 10A, which is here. And that's here. There we go. I'm going to set up a place to put scores on my other screen. Get it out of the way. All right, good. And let's see, I got 16 students. Okay, good. So I'll wait a little longer and see if, oh yeah, people are still coming in. Okay. All right, I'll give it a few more seconds. Looks like that's it. Okay. So which phone lets you add malware from a different server? Okay, that's file inclusion, not command injection. That doesn't let you directly add a file. Adding malware from different servers is typically done with file inclusion. All right. What vuln is caused by PHP's eval function? Okay, that's command injection. You get to evaluate something, you get to put commands. Now, you might try to use those commands to connect to a server and download something, but you often are not able to do that. And yet you can still do commands like ls and cat to reveal the contents of files. All right. All right, how do you detect file system modifications? Procmon, we use this all the time in the malware analysis class. You can see everything malware does, every registry read, every registry write, every read and write to the file system, and so on. This is a basic activity to analyze any code to see what it's doing. All right, and which defense puts the web server in a restricted file system? All right, it's chroot. One of them had chroot and procmon. It's ridiculous. Chroot is the thing that does it on a Linux system that lets you work in a subfolder and have no way to get out of that subfolder. So let me record these winners. elam3 looks like a real name or something close to it. 3 elam3, Ken Tan, and 3 Gary Lynn. Good. All right. So let's get back to here. And all right. So this is a real important vulnerability. I hear a lot about it. XML external entities. Now, XML is a language used to make requests to servers and get responses, and it's real important these days. That's what AJAX is, asynchronous JavaScript and XML. It's used to make responsive web pages that will make requests for a little bit of data, not the whole page. Like Google Maps is one of the nicest examples. You can drag Google Maps to the right and it responds right along because it doesn't reload the whole page. It loads just a little bit, like a quarter inch at a time, to fill in the page as you drag it. So these things are quite powerful, but unfortunately, they have features in them that can easily be abused. So here's the example from the textbook. If you send a post to search for something, and you see down at the bottom, you send something called a search term, and it's put in an XML container. So it's a search object, and that has a search term parameter, and that is nothing will change. This is the way it's structured. And so the server replies by saying no results found for that expression. This is just an example of a search, sort of like a Google search, where you're passing up a search string and it's searching some list of objects for things that match the search. So I found the Acunetics description today, and I thought it was more clear than one in your book. So I want to talk about this. I think this goes through it nicely. So here's an example where you post foo hello world /foo, and the response is hello world. So it just prints out the foo input. This is essentially the same thing as we saw before. But now here's an XXE payload. So what you do is instead of just passing foo, before you put in foo down here, in foo you put hello ampersand bar semicolon, which is going to, the ampersand and the semicolon mean it is a meta character. That bar is some kind of variable, and you define that variable in the doc type header. You see it on the left. So you define an entity bar, which is world, and now the response is hello world. So you have defined a variable inside the XML structure, and that variable is filled in with what you put in there. So this is relatively harmless, but it does lead to some ability to exploit it. You can, for example, do this. You can define bar standing for world, and then you can define T1, which is bar bar, and T2, which is T1, 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 and T3, which is T2, T2. So now the T3 is a lot of worlds. So this is sort of like a zip bomb or denial of service. It just shows that we can define a lot of variables. We can define variables in terms of variables. So we're getting some control over the server. And here's the one that really matters more. You can, instead of just defining an entity like we did here, where you just define a variable that stands for a fixed structure, you define a system object, and the system object lets you load it from a file somewhere. And this is so you can do file inclusion, which is so you can do code reuse. JavaScript has it, PHP has it, everybody has file inclusion. So you can put up some file and then include it in many other files. But it's dangerous. Here, you can now refer to a file that is clearly not an XML file, but the system is too dumb to detect that. And so now when you print out the XXE object, it will fetch the contents of its password and return it to you. So this is like PHP local file inclusion that you're getting here. And here's another one where you can refer to a remote server. This is remote file inclusion. You again define a system object which tries to fetch the file, and it fetches it from some remote server. So any server that the web server can reach, you can go to and fetch anything it has. So here it's able to read a file that is on apparently a shared file on the local network behind the firewall. So what you've done here is you have used the web server as a proxy server to attack other things inside the firewall, which were not directly connected to the internet. All right, and so here's the description for your textbook, how they do it. These are things called entity references. So here's the simple entity reference where you define test ref to be test ref value, and that will just fill it in. All right, and here's where you define a system object which fetches it from a file, and here on a Windows server, he's just fetching Windows WinInny again. And so you will see the WinInny, and the WinInny has this stuff about 16-bit apps and such. All right. So you now can connect to a server behind the firewall. So you connect to 192.168.1.1 on port 25. So now you're connecting to an email server behind the firewall. And so now you can send a series of these with different IP addresses and port numbers, and then you're performing a port scan of the network behind the firewall. You can retrieve any data that will respond to this kind of request. And if you find vulnerabilities on them, you can send attacks to them. You can also perform denial of service. You can put dev random as the file, and that will make a long stream of random bytes. I tried it, it worked on my Mac. You can print out 16 bytes of dev random. If you print them out again, you get a different random 16 bytes. On you go. And then, okay, so that's XML entity expansion. Another one is injecting into SOAP services. SOAP services, Simple Object Access Protocol, lets you fetch objects of any kind the same way you would fetch web pages with gets and posts. So here you send a post, and this is a banking app. So you have a from account, an amount, a to account, and then submit. So this will make a request to move money from one account to another. Now this goes onto a web server, and the web server then sends a message to the, in XML, well, it looks like XML anyway, but I guess it's, so it sends it to the database server, whatever it is that actually holds the money. And so it sends from account, amount, cleared to account, and it sends it with a parameter called cleared funds false. So this is a request to move money, but it has not yet been approved. It has not verified that the money is really there. But the point that matters to us is it includes data that came from the user. The user gave you the account number and the amount, and the same account number and amount appear here. So if they're not sanitized, we can inject meta characters in the account numbers. So what you do is you can inject it in the amount. You see the red here. I put in 1430, and then I put XML in there, and then I end in a comment tag. So now the SOAP message that is created from that to go inside the internal servers at the company now has this result where it moves an amount and the cleared funds is true, and the to account comments out part of this. And so I'm able to now send a message which will appear to have already been approved and not one that's requesting approval. So that's a pretty good one. All right, and so that's the game. You can also have an unmatched comment tag, and that might create an error or it might pass through depending on how their parser handles this sort of thing. So if you want to find these things, you just inject a closing tag. That should create an error because there's no matching opening tag. If it creates an error, try putting in an open and closing tag. And if it doesn't have an error, then you can now inject extra tags without getting caught. And all you have to do is figure out what tags to inject that will have the desired result. All right, so you can try this to see if tags are stored and echoed back to the user. You can inject opening comments and closing comments in another parameter, and that will cause some piece of the message to just vanish, and you may be able to create interesting conditions. So if you want to prevent this, you got to filter out all these special characters or HTML encode them so they stop being special characters. Less than, greater than, and slash would be a logical way to do it. Then you can inject into HTTP requests. This is used to be called HTTP response splitting when I first came across this, and we'll see a few varieties of this. All right. Oh, this one. All right, we're doing redirection. Response splitting is coming up. Anyway, so if you have user-controlled data that is incorporated in a URL, we have this parameter location, which is online woblogs.net. And so this is sent to the server in a post, and that's used to recover something. So if I send a location, which is an IP address and a port number instead, then it will try to fetch something from that port number using HTTP. So it will show the SSH banner and then claim there's a protocol mismatch because the request is not a valid SSH request. But then I can see that I did connect to that third party, that other service I was not supposed to be connecting to. So you can now use your app as a proxy, attack other services, connect to hosts on the internal network, and so on, just like the other ones we talked about. Then there's parameter injection. Here I'm supposed to have a from account, a to account, an amount, and just submit. And that would be send a post which will eventually try to move money around. But what I can do, it has this cleared funds equals true. And what I can do is I can inject this. Look at the to account parameter at the bottom of here. I have an account number, and then I put in %26, which is ampersand, cleared funds equals true in URL encoding. So I have injected two parameters where there was only supposed to be one. So if this is processed and decanonicalized and then passed on, it will cause it to send a request that specifies cleared funds is true at the wrong step of the process. Now that's going to mean that this is called parameter pollution. I will now have two instances of cleared funds. I will have injected a cleared funds equals true, and there will be another parameter added by the server that says cleared fund equals false. Now you can have two assignments of the same parameter, but there are no rules as to what should happen. So it might use the first one or the last one or combine the two. So if you're lucky, the one you are able to inject will win, and you can now change a parameter that was not supposed to be under your control. All right, so the original backend request looked like this, and the final one now has this cleared funds equals true. So I can perhaps get away with it. All right, so the backend request has the added parameter, and I may be able to move money that I was not authorized to move. All right, then there's URL translation, which is another issue. There are, Apache has mod rewrite. It is very often the case that you rewrite the request from the user into another form to match the next form. For example, REST style parameters, where you have parameters that appear in the query string with name equals value in one form, but you want to turn them in the other form where they just appear in the URL with a slash as if they were a directory. This kind of thing happens a lot. So you have mod rewrite with rewriting rules. So this will change a RESTful style thing, pub user Marcus, into the other form where you have mode equals view and name equals Marcus. So it picks some parameters out of that and rewrites it uses them in a different way. Part of those parameters turn into part of the file name, other parts of it turn into parameters. So all you have to do is carefully construct something. And again, you can add a mode equals edit here. And now it will change the request to have an extra mode equals edit at the end. So you are now able to change an extra parameter that you weren't supposed to have control over by putting it in something that looked like a directory name. And another one, this is the one I was talking about before that is very much like HTTP response splitting. SMTP servers just take lines of text ended by carriage returns or line feeds, and they find email messages in them. And they just have a whole stream of these things coming by. So you can take a request to send an email and you can turn it into 2 requests to send an email, and they will often both get processed. This is what happens when you have modular processing, where one preprocessor does something and the next processor does not know how many requests should have come from the previous one. So here you've got a feedback form where you can put an email address, subject, and comment. So if you fill this out, it will send this to the server. And that's fine. But suppose in the email address, I put in a %0a. That's a line feed, which on a Unix system will terminate the line. And now I can put in BCC : and send extra BCC to someone else. So now I can send this. I was supposed to be putting my email address, which was just the from address, but now I can put a BCC and send a copy of this to some other people with an email address totally under my control. So I can take an email server that was supposed to only go to their feedback system, and I can use it to send spam to some third party. So that's one issue. And then you can inject SMTP commands. Carriage returns are what determines lines. So what you can do is I can now, in the from address, I can put in subject equals site feedback and message equals foo. That will create an SMTP conversation here, which is normal. And notice the period at the end. The period is what terminates an email. So if I can inject periods, I can turn one request into 2. So I take my from address and I put in everything, and then I put in %0d, %0a, foo, %0d, %0a, then a %2e, which is a period, and %0d, %0a. So at the end of the first line, I have now completed the original email, and I can now inject an entire new email with a from address from anywhere I want, going anywhere I want with any kind of message. So I can now take your email server, which was only supposed to be receiving comments, and I can use it to send spam, which is totally under my control, to other people. And it looks like this. The first one is the original feedback comment. I was able to inject the period, and now I was able to inject a whole email that goes anywhere I want and does anything nasty on your email server. And then people will complain to you, and you'll get blocked on spam lists and all that jazz. All right, so to find these things, inject in parameters, try carriage returns and line feeds, and see if you can inject dots and so on. All right, so here's what you should do to prevent this. Make sure your email addresses don't contain, have the wrong structure, have carriage returns or line feeds in them, and don't let people inject any data that's a single dot. That'd be a good start. All right, so I got some Kahoots about that, which are back here. 10B. And here. All right. And I don't think I got any chat. Nope. All right, good. All right, I'll give it a few more seconds. Oh, okay. Well, wait 10 more seconds. All right, I guess that's it. All right, which one uses a custom doc type? XML entity expansion, XXE. That's that one that lets you refer to a system variable, which could then have a path. All right, which one uses HTML comments? All right, that's soap injection. That one you would put in an opening comment in one part and one tag and in one parameter and a closing comment in the other parameter and remove a whole bunch of code to see what happens. All right, which one uses a line containing a single dot? That's SMTP. The single dot ends in email. All right. And which one sets the same value twice? All right, that's parameter pollution. Good. All right. Get down here and record the winners. Ken Tan has won twice. Good. And Phil Fry. Okay. All right, and Gary Lynn. Good. All right, I've got the winners. All right. So I think I'm going to stop the recording, but not the share for a little while. So